Hey guys, so we're going to do some calculus practice. So first off, I have to apologize on this first one because I had started making a video and realized I forgot something and stopped it, and so we're going to pick up where we left off. But it says the velocity of a car which starts at position 0 at time 0 is given by the equation v of t equal to 12t minus t squared for t is greater than or equal to 0 and t less than or equal to 12. Find the position of the car when its acceleration is 0. Alright, so what we did to start with was I just explained that the velocity is the first derivative of the distance function, and therefore to get acceleration we need to take the derivative of that because the acceleration is the second derivative. So here we have the acceleration, and we figured it out that t is equal to 6. We just plugged in 0 because we have time of 0. So here we get t of 6. So then over here, this is just the integral of it, because we know that if they gave us this equation, we need to take the antiderivative or the integral of it to get back to the distance formula. So taking the antiderivative of that gives us this, which is d of t. So then we want to plug in the 6 that we got over here to get d of 6. So whenever we do that, we get 6 times 36 minus 72. 6 times 36 is 216 minus 72, which is equal to 144. And sorry that I messed up the first time and couldn't walk you through that more, but we'll move on to the next one. So this one says calculate the integral of 3x squared e to the x cubed dx. So this one wants to trip up a lot of people because you automatically, for me, I automatically see this e to the x, and I know that the derivative of this has to do with another e to the x because it doesn't change. But what throws a lot of people off is this right here. So I want to kind of walk you through something to show you where I got confused and show a much easier way to do this. So to start with, if we're talking about just e to the x, so we have e to the x d dx. So we want to find the derivative of that. It's just e to the x. Well, if we take the integral of e to the x dx, we get e to the x. But then if we take e to the x cubed d dx, we then do chain rule because it's e to the x cubed because that doesn't change. And then we need to find the derivative, so d dx of x cubed, and that is the chain rule there. So therefore we get e to the x cubed times their derivative of this, which is 3x squared. So if we have this as the derivative of this, then if we take the antiderivative of what we just got, that means that our antiderivative of this is this. So that takes us to b. So just to explain that again, what I'm saying is that if we have this and we want to take the derivative of it, because I just wanted to walk you through it, then you get this, and because of the chain rule we also have to take the derivative of this, which is 3x squared. And so if we know that this is the derivative of this, then that means that the antiderivative of this is this. Alright, so we'll move on now. So the next one is find the area of the finite region between the graphs of y equals negative x plus 2 and y equals x squared minus 4. So the first thing to do is to graph this in your graphing calculators, just so you know what the graph looks like. And I'm going to try to roughly draw it here. But it looks similar to this. Sorry, this should be up here. And then here. Also, if you look into your calculators, you can find that where this is 2, 0, and negative 3, 5, just by looking at the table in your graphs. And we're looking at this region in here. Alright, so our first thing to do is set these two equal to each other. So if we set them equal to each other, we have negative x plus 2 is equal to x squared minus 4. So then all we want to do is just bring it all over to one side. So you get x squared plus x minus 6 is equal to 0. So then if you factor this down, you get x minus 2 and x plus 3 equals 0. So therefore that tells us right there that we have points at x equal to 2 and x equal to -3, which as you can see our table also found for us. So then to find the area of this, the area is the first integral, like one integral, so you want to take the integral from -3 to 2 of, you want to always take the top graph, which this is the top here, which is the -x plus 2, -x plus 2 minus the bottom graph, which is this, so x squared minus 4 dx. So then you get the integral of -3 to 2. If we combine all like terms and distribute the negatives, you get -x squared minus x plus 6 dx. So then we take the integral of that, we get -1/3 x cubed minus 1/2 x squared plus 6x, and we want to evaluate that from -3 to 2. So then what you do is, this is always it's the top minus the bottom. So therefore, if you just plug this in, we're going to say -1/3 times 2 cubed minus 1/2 2 squared plus 6 times 2. We're going to have all of this minus -1/3 -3 cubed minus 1/2 times -3 squared plus 6 times -3. Alright, so then if you plug some of this into your calculator, if you plug this whole thing in, and remember to use parentheses, they're very important, especially whenever you use your exponents, but you end up getting 22 over 3 minus -27 over 2, which then if you also plug that into your calculator, then you get 125 over 6. And there's your answer. That is the area of the region between these two graphs here. And that's all for tonight.